Okay, so we just got started with a student's lab write-up, and we're grading it today, and I'm going to be putting the grades right into this section of the document, and hopefully all is going to work well on the recording today. But one of the things that I demonstrated was to go into a Word document, and come on, let's go right here. Okay. And what I showed was that by holding down the Control key and hitting the Enter key, I can make this go down to the next page, and I have all of this space up here from the first page. And as I put my use my down arrow, I'm coming to here, and now I just went to a new page. Okay, and my other stuff that I did is right down there. So as I go back up now, the nice thing is that I can add things here. So I'm going to hit Enter key again without hitting Control. Why did that do that? That shouldn't have done that. Here we go. Down key. Oh, this is being stubborn. Okay, here. Now, Enter. There we go. Now I can type more stuff in here if I want and keep doing tables and charts and text, whatever I want to do. And then when I'm done with that, down arrow, and I'm down to the next page where I put my other stuff. Okay? And we apparently got a bunch of pages here. But at any rate, that's what Control Enter will do for you. And so let's go back in and let's look at our actual grading of the student work. So we're getting 2 points for the rubric. We are going to get purpose, materials, and chemical reactions. Purpose, materials, chemical reactions. Easy grade. Okay, procedure, revised. Okay, I'd like you to put this as a new page when you're that close to the bottom. Okay, just a better way to do business. And now I'm looking at 31 steps. I'm just looking quickly at some of the wording here to see how he's done. Next, go get the diluted phenol red. Make sure it weighs at least 8.5 mils, plus or minus a mil. Okay, that's fine. And get the Ziploc bag now. And yeah, okay. He's telling you in good details. Again, when you're this close to the bottom, especially when you're going to have a data table, I would do page break here. So page break. And let's go ahead and get his procedure in here for 10. Now, observations. See, you don't have your headings when you go in here. Is there a reason why you made this so big?
I just put a table in, and put the table from the box, and that's how it
Google Docs. Okay, whatever. Can you go in and change the size of that text?
Yeah.
Will that work?
Yeah.
And will it make the box smaller?
Yeah, I can control it.
Really? Okay. Yeah, why don't you make that a little bit smaller? Again, no points off. Now, here's something you do get points off for. Okay, 3 decimals. 3 decimals for all masses. Okay, -1, -1, -1. It's all the same problem. Okay, that'll be an easy one to fix, right? So this should have both the mils and the mass, grams and mass. So the grams, you need to go back and look at your original data, see if you don't have a couple more decimals there. Okay? And here you need 3 decimals, or 2 decimals, because that graduated cylinder is capable of doing that. 2 decimals. Okay, -1. 3 decimals, -1. Oh, that hurt a lot, didn't it? Okay, if this was your paper, you'd be a little discouraged right now, yeah, about your data table, because you just lost 10 points. Okay, so that would come out of the observations section, and I wouldn't take more than 10, so 1, 2, 3, 4, 5, 6, 7, 8. That would knock his observations down to 2. Now, do you see what I mean? Sarkis is a really good student, and he just made a careless mistake. And it would have cost him big time had he not had me grade his paper. Are you guys making notes? Xavier, you really need the points, man. You should be tuned in big time. You should be taking notes on this. What did he just lose points for? Huh? No. No. He lost points in his observation section, but why? Yeah, because you weren't paying attention. So do yourself a favor and tune in. There's big results here, buddy. Big results. Big results. 45 points on the line. You don't want to lose points this easily. He didn't have 3 decimals. See? 6.71, 2 decimals. All masses have to have 3 decimals. Automatic point off for each one that you don't have 3 decimals on. Okay, observations. I felt an exothermic reaction right when we mix the chemicals. The color of the chemicals turned from a pinkish white to a mucousy yellow. That's funny. Snot. The texture got very slimy, but looked like if you put something in it, it would dissolve. Okay, that's an observation. Felt as if the bag got sort of lighter when the gas formed. Really? Okay. What you're experiencing here, it seems like it's lighter because the volume is bigger. It's actually the density change, not a mass change. Okay. So just to fine tune that one. As time passed, the mixture got colder, which is an exothermic reaction. Okay, or an endothermic, yes. And after 5 minutes, the bag settled and the mixture looked like a yellow molasses. Okay, the mixture also had a slight green in it. Okay, all those are good observations. He didn't make any conclusions here, which is perfect. So that part is good. So we got a big deduction on the observations simply because of the masses not being right. So he'll obviously get this fixed. So I can almost guarantee you that he will have close to a perfect paper. Let's see what he did on conclusions. Okay. Again, you could take your text down so you don't have quite so many pages. Conclusions. Based on my observations of the lab, I can conclude many things. That is what conclusions are all about. He said, based on. That is good. My observations. That's what a conclusion is. I'm going to take my observations and I'm going to make some conclusions on them. One being the first reaction that happened when the two chemicals mixed together was exothermic. Perfect. Because. And he's got the because. Beautiful. Good. Okay? Because heat and gas were produced. Okay? Two chemicals mixed together was exothermic. And so, which would mean the substance produced was an acid, which is our first reaction. Yeah. Which could have resembled stomach acid which we humans produce. Very good. Nice tie-in. If another experiment was to be made, I would put some sort of solid in the bag along with the other aforementioned chemicals. Ooh, nice word. To see if it would dissolve. Okay? And the conclusion being that the post-reaction was endothermic. Actually, it's the active second reaction. Okay? And post-reaction is not a bad way to say it, but you're really saying that not after the reaction, but during the reaction, it got cold. Because the second reaction uses hydrogen and produces CO2, and that dude is endothermic. As the heat had died down and coldness was produced. Okay, I also noticed that the bag's mass after 5 minutes of the reaction had gone down by about 1.4 grams. Now, here's the most important conclusion in the whole lab. Are you all on this? I'm hoping what I'm going to read is something about the law of conservation of mass. That is the first law of chemistry. Okay? Since the law of chemistry, there it is, beautiful, is true, this weight change must be caused by a slight error, that being our group not. Oh, okay. Did you confirm that it wasn't fully closed?
Yeah, is this the one that
Okay, very good. This is excellent. I couldn't say anything bad about that conclusion. That's the best conclusion I've read all day. So this is a 10, and the procedure handwritten, is that stapled to the back? It is. Oh, this is great. Okay, 5, 15, 17, 27, 37. Second highest score today. Okay, and I know that when he goes home, he's going to wind up with a straight 45, because he will fix those problems. Good job, Sarkis. Now let's see if that